Adam and Jamie are ending their final ever revisit
That was a crack!
with a bang. They're testing whether two simultaneous explosions of the same size can really cancel each other out. And after test one, the control data is in.
So the data was clean. The nearest sensor showed 135 psi, and it evenly lowered to the last sensor at 25 psi. Now for the next test, instead of one blast, we're going to have two blasts on opposite sides going off at exactly the same time, the same distance. And those numbers, those pressure readings, will change. How exactly, we don't know. They could go down, they could go up, they could cancel each other out. But that's what we're looking for.
To find out, the guys salvage what they can from test one.
3, 4.
That's good.
Awesome! Ha! I love that we don't have to replace this.
And begin to set up for test two.
Good.
But Adam's already got concerns.
Look, we often make a joke on this show that failure is always an option. In this case, for this experiment, it's not. And allow me to explain. When we say failure is always an option, we're actually explaining that we have no bias as to how something turns out. So what we're really talking about is a failure of our expectations is always an option.
Oh! Any result's a result, that's for sure.
But we can't survive a failure of our methodology. And in this case, the methodology for this experiment is everything. We have to have those two explosives go off simultaneously and perfectly equidistant from the center sensor in order to get the reading that we're looking for. If we don't get that, it's going to be a heavy-duty reset to try and get it again.
To try to get two identical booms, the guys are using exactly the same quantity of explosive that's positioned perfectly equidistant from their data rig. And by using exactly the same length of detonation tube, they're leaving nothing to chance.
Fire in the hole!
But will that be enough?
Okay, double explosion in 3, 2, 1, go!
Well, that was a bit of a cold shower. I pushed the button and nothing happened. Well, almost nothing. Actually, I did watch the spark travel down the tube, but when it got to the water's edge, it stopped, which means that we may have gotten some water. But what it really means is that somebody owes us a case of beer, because that's what that means in the bomb world.
Rules aside, the guys quickly replace the det tube, and then it's good for take two.
Okay, here we go. Count it in, Mr. Heineman.
Okay, two blasts canceling each other out, maybe, in 3, 2, 1. Wow. I felt that one.
That was a bone rattler. Holy.
In real time, it's impossible to see if the experiment was a success. But the high speed shows it was exactly that.
This is really, really beautiful. First of all, this camera angle is shooting at 4,000 frames per second. And you can actually see here from one frame to the next, boom. It's a perfectly simultaneous explosion. That's exactly what we were looking at. Now, there's some cool stuff as you advance through the frames. You can start to see the actual shock waves there, these two bubbles. And as they increase, the gray line here above the water, you can actually see the cross of the two bubbles intersecting. We have sensors in place that will tell us what's actually happening there. Is it increasing the power? Is it decreasing the power? I honestly have no idea. And I might be overexcited because I was just rattled by an explosion.
Wow.
But I think this is pretty awesome.